we want to evaluate this antiderivative. We need to make some sort of substitution. And this is not, there's no exact way of always finding the right substitution. Sometimes you just got to sit and think about it for a bit. And they gave us a hint. With this hint, you want to think that sine squared is the same thing as 1 minus cosine squared. And that cosine squared is the same thing as 1 minus sine squared. You can rearrange that formula. And let's see. I think the best way to do this would be to solve for cosine. No, I think I got that backwards. Is that right? Yeah. Because that's going to be 1 minus sine squared x. So we haven't done calculus yet. We're just rearranging. We got cosine to the third. So I'm going to take a cosine squared and replace it with 1 minus sine squared. And I'm left with still a cosine. Right? Because this is cosine squared. Cosine squared times cosine makes cosine to the third. And the reason why I did that is because I was thinking about u substitution. If I let u represent sine x, then I've got u squared, 1 minus u squared, and I need a du. I've got it with that substitution. Now, it doesn't come easily to students when they're first doing calculus, so it takes a while. It's just trial and error. You know, what if I solve for sine squared x and plug that in? Does it work? No? Okay, well, let me try to go back and solve for cosine squared x. Okay, that's what it looks like with u substitution, so we can distribute that u, the u squared, I mean. Now, the antiderivative, it's 1/3 u to the third minus 1/5 u to the fifth plus some constant c, and then the final answer is when you plug sine x back in. So 1/3 sine cubed x minus 1/5 sine to the fifth x plus some constant c.